All right, we'll go ahead and get started. So today we're going to cover ratios. And when we're done, we're going to apply this, what we learned, to a game of trash get ball. So I have these very pretty colored bins here that you can thank Dollar Tree for. And we'll have to figure out how far away we want to throw from and all of that, but we'll do that at the end. Your very last page of your packet is going to be the worksheet you use for that. You want to get a glance at it and see what you'll be doing. My guess is the actual lecture portion will take 35-ish minutes, and then we'll spend the rest of the time doing the trash get ball and filling out the activity sheet. Okay, so that's the plan for today. So let's look at what a ratio is. All right. So a ratio is a fraction used to compare two measured quantities whose units are the same type. And that should be the first definition on your sheet. Okay. Also, equivalent ratios are ratios that express the same relationship. We'll go into more detail as far as what equivalent ratios are, but to kind of give you a real quick simplified idea, two fractions like 1/2 and 2/4, those are equivalent ratios. They're two different ratios that express the same relationship of 50% of something. 2/4 and 1/2, both 50%. Okay? All right, so you can write ratios in 3 ways, and that's what that first section is for. So 3 ways to write ratios. Okay? All right, so let's see. In this class, when everybody shows up, which we're just a couple people today, so it won't be exact, we generally have 2 men, I believe, and 8 women. So I'm thinking now, looking that we have more women than I thought. So, or we have 3 men. Sorry. Oh, hey, you know what? Today we have 2 men. So Chance does not need to know about this. Okay? Don't tell him that I didn't count him as a man in this calculation. But anyway, I'm totally editing that out of the video, y'all. Okay, so there will not be any evidence. All right, so we're just going to say there's 2 men and 8 women because that's what I have on my paper and I don't want to mess myself up. All right, so we can write this with words. We would say that there are 2 men to 8 women. We can write this with a colon. So it'd be 2 men, 8 women. It's also common to see them leave off the words and just write 2:8. So if you see that, please, that's the same thing. And you can write it as a fraction. So 2 men to 8 women. So we will use all 3 of these today. In mathematical papers, if you're ever reading something for one of your other classes and it talks about ratios in the paper, this is the most common, right here. And that's usually because, as you can see, if you leave off the words, it's the shortest. So why wouldn't they use it? All right, okay, so once you have this written, if you'll flip to the next page, you'll need the picture that I have. I'll give you guys a minute here to write this down. You're still right. All right, so you see I have 4 circles and 2 triangles. So we're going to write out a ratio of circles to triangles using the 3 methods. So ratio of circles to triangles. Whenever you're writing ratios, it's important to make sure and list the numbers in the order that it's given in the instructions, all right? So since this says circles to triangles, we want to list the number of circles first and then the number of triangles second. So with words, I'm having a hard time finding a good marker I like. Oh, that's better. Okay, with words, we have 4 circles to 2 triangles. With a colon, we have 4 circles, colon, 2 triangles. Regardless of how it's written, you still read it 4 circles to 2 triangles. So if you were like reading a paper out loud, say, because I was looking at y'all's majors today to kind of get an idea of where you guys went ahead and kind of try to incorporate it in my class, and I noticed that a lot of you are child development or elementary education, all right? So if you were in front of a class, and this is going to be, I looked it up, this was, I think, 5th grade. 4th or 5th grade is when they learn this. You would need to explain to them that regardless of how it's written, when you're reading it out loud, you say it the same way. And so whenever you're reading it to your students, you're going to, and you read this, it's 4 circles to 2 triangles. Right? And then also as a fraction, we have 4 circles to 2 triangles. All right, and there's one more thing I want to add. Another way to read this, your book uses circles to triangles. Another common way is to say, for every 4 circles, there are 2 triangles. Or there are 4 circles for every 2 triangles. All right, so I'm going to write that over here just so you guys will know. For every 4 circles, there are 2 triangles, or you can say it as for, how do I do this? For 4 circles, where is this? For every there. Let's just leave with that one. The other one's more wordy and kind of weird, so I think I'm just gonna stick with that one. All right, okay, so you guys try to your turn. The next one I give you a problem and ask you to write it in the 3 ways. So, okay, yes, so it's gonna be the one that's about a bag has 6 marbles. It technically says a bag has 6 marbles, but it's supposed to be has, okay? All right, okay, so we'll start in the back. We always start in the front with Summer, and she's probably like, I'm tired of being first. So Tanya, we'll start with you. How would you write that in words?
Okay, that's right. 3 red marbles to 3 green marbles.
Perfect, yes. 3 red marbles to 3 green marbles. Did everyone get that? Yes.
I do have a question. I put like a bag of, like, do you need that part? Like, I did have like a bag of 3 red marbles.
You don't need to add bag up part.
Okay.
Any other questions about how to write it with words? All right, Jake, it's your turn. How did you write it with a colon?
All right, 3 red marbles, colon, and then 3 green marbles.
All right. Next time we're talking about boxes because that's shorter than marbles. Green marbles. All right, and we are at Taylor. How did you write it as a fraction?
3 red marbles over green,
Mhm.
or 3 green marbles.
Right. Oh, I just realized you can't read the board, can you?
I can see it if it's kind of like mushed together.
Okay.
You see me leaning in and.
I'm just gonna think you're super like intense about this subject.
No, I make the words out. It's just like mushing in.
Gotcha. Taylor doesn't have her contacts,
Yeah,
by the way. That's
I'm
where
listening really hard.
Gotcha. Okay, so 3 red marbles, 3 green marbles. All right. Are there any questions about how to write a ratio using any of these methods? All right. Okay. So now let's look at equivalent ratios. All right, so like we talked about before, equivalent ratios are basically, think of them almost as like fractions where one is reduced and one is not. That's like the most straightforward way to think of it. So at the beginning of this class, we said there were 2 men to 8 women. Ah, that's not how you spell women. There we go, okay? Is it also true that we could say there is 1 man for every 4 women? True, yeah, we could take Dallas and we could pair him with Lisa, Mariah, Summer, and Taylor. And then we could take Jayton and pair him with Tanya, Rachel, Rebecca, and the other imaginary woman that's not here. Or I guess Amanda, because she's not here, so we can, all right? And so both of these are true. This is an example of equivalent ratios. All right, so these are equivalent ratios. Okay? An easy way to see that is if you set up your ratios as fractions, if they're equal, then you have equivalent ratios. If you are uncomfortable reducing fractions, if it's something you haven't done in a while and you're like, I don't even remember how to do that, all you have to do is get your calculator, take 2 divided by 8, get the answer, which is going to be 0.25. Take your calculator and get 1 divided by 4. That's also going to be 2.5. And you can see that they're equal. All right? So don't let a fear of fractions keep you from doing this. Just convert everything to decimals. And also get a book and practice your fractions. Because if you're going to be teaching children, you got to know how to use your fractions. Okay? I don't want that to hold you back in this class, but it will hold you back as a teacher. So, okay, so let's look at example. I don't know if I put this on yours or not. Did I give you guys example 3? Are the following ratios equivalent? Okay, I can't remember what I took off. All right, so we want to know, are the following ratios equivalent? This is example 3. 3:4 and 9:12. There are 2 ratios there. We want to know if they're equivalent. Let me write this on the board here. So So the easiest thing to do is to take both of these and convert them to fractions. All right, so our first number goes in the numerator. Second number goes in the denominator. So 3/4. And we don't know if these are equal, so I'm going to put an equal sign with a little question mark over it. That is not like proper math notation, that's Kirsten notation, okay? Just because we don't know if this is true or not. And then I'm going to take 9, put it over 12. All right, at this point, there are two things you can do. You can either ask yourself, can I reduce 9 over 12 to equal 3/4? And if you feel comfortable with fractions, yes, you can. 9/12 does reduce to 3/4. If you're not comfortable with fractions, just plug both of these in and get decimals, though I don't know what they are. 0.75, okay, so this will come out as 0.75, 0.75. Since these are equal, they are equivalent ratios. All right, okay. Everyone look at example 4. We want to find out if 2 to 3 and 8 to 11 are equivalent ratios. So 2 to 3 and 8 to 11. So I'm going to start going around again. I was at Rebecca. All right, how would I write 2 to 3 as a fraction? 2 over 3, perfect. And Rachel, how would I write 8 to 11?
8 over 11.
Yep. Okay. So now we want to find out if those are equal. All right. Lisa gets a pass because she had throat surgery. So Mariah? No. Okay, and why not? Correct. 8 over 11 will not reduce. So if you're good with fractions, this will not reduce. Also, can someone tell me what this is as a decimal? 8 over 11.
0.72, so on.
Okay, so 0.72.
And 0.72, not 20.
And 2/3 is 0.66.
Yeah.
So as you can see, these are not equal. The standard sign, and now this is actually standard, not just my random method. The standard sign for things that aren't equal is you put a slash through the equal sign. So this means 0.66 is not equal to 0.72. So these are not equivalent ratios. All right, so there's 2 your turns next, and they're a little different than normal, so give them a shot, and then we'll talk about what you got. Okay, so I'm gonna start with Summer, and I'm gonna have her give me what ratio she chose as equivalent and what ratio she chose as not equivalent, and then I'm just gonna go around and get them from all of you. Mariah, if you could please read Lisa's for me whenever I get to her. All right, Summer, what'd you get for your equivalent?
I did 2/6 is equal to 8/24.
Oh, fancy. Okay, that is right. And what did you get for? I was thinking like 2/6 equals 1/3. Okay, all right, not equivalent.
And then I did 2/7 is not equal to 3/4.
That is correct. 2/7 is not equivalent to 3/4. All right, Dallas, what'd you get for your equivalent?
I got 6/18 and 3/9.
Okay, perfect. And for not equivalent?
2/5 and 9/11.
Perfect. All right, so Mariah, can you tell me Lisa's?
Okay, on the equivalent, she did 1/3 and then 3/9.
Okay,
And then not equivalent is 1/5 and 4/7.
perfect. All right, and yours?
I did 2/4 and equivalent to 1/2.
That's the kind of example I was thinking of. Which is, I'm very impressed, y'all. That is not a diss. It's just you guys went above and beyond. All right, and then the not equivalent.
2/5 is not equivalent to 7/11.
All right, Taylor. Oh, you didn't? Oh, because you can't.
that great.
Okay, all right, that's fine. Okay, Rebecca, did you get any?
I did the 1/2.
Okay, what'd you get for your not equivalent?
Well, this one is kind of tricky. I did 3/5, 2/3.
Is not equivalent to 2/3?
Yeah, it's close though.
It is close, but you're right, it's not. All right, what did Rachel get for equivalent?
2/2
Okay.
is equivalent to 2/2.
Yep, that is perfect. Yes, that is true. All right, and then for not equivalent?
2/3 and 2/6.
Yep, that is correct. All right, Jayden, what'd you get for equivalent?
I put 3/6 and 1/2.
For equivalent? Okay, that is correct. And 1/2. Okay, and what did you put for not equivalent?
I only got 1/2 of that one.
What'd you get for the 1/2? We'll finish the other half.
I got 2/5.
2/5. All right, so we do know that 2/5 is definitely not equal to 1/5, right? Those are not equivalent ratios right there. All right, and Tanya.
Okay, I got 3/9 and 2/6.
3/9 and 2/6 is equivalent?
Yes.
Yes, okay, because they're both 1/3. Yes.
Yes.
Okay, yeah. And then not equivalent?
4/4 and 1/2.
4/4. So like 4/4?
Yeah.
Oh, okay. That's perfect. You're right. Those are not equal. All right, awesome. Okay, so these are all correct. All right, Taylor, I will show you your calculator afterwards. How you can do this is you find two decimals that don't equal. I'll show you how to convert them to a fraction in your calculator, and that'll give you your non-equivalent. Okay, all right. So any questions about equivalent, non-equivalent? You good? Okay. All right. So now let's take this and let's try to apply it to some like word problems, basically. All right, so this is going to be example 5, finding the missing part of equivalent ratios. All right, so let's look at our original ratio we had of 2 men to 8 women. All right. So let's say that next semester I teach this class again, and I was to tell you the ratio of men to women is the same. So ratio is the same. But I have twice as many women. And on the board, I'll write twice as many female students, because that's technically more correct. So if my ratio is the same, for every 2 men, there are 8 women, but I have twice as many female students, the question we want to answer is, how many male students are there? Yes, we're going to work through it though, Jane. For all of you that are thinking 4, yes, you are correct. We're going to actually walk through it. All right, so how you want to do this is you want to set up equivalent ratios like we just did, except you're going to have an X that takes up the spot of the thing we're looking for. All right, so we know the original ratio we're given is 2 men to 8 women. For brevity purposes, I'm just going to use the numbers only. So we have 2/8 equals, now remember 8 was our number of women, and I said we have twice as many. So twice as many is how many females? 16, because we just take 8 times 2, 16. And then we put an X here, because that's what we don't know. This is our number of male students. So last week we talked about cross multiplying. So we're going to talk, that's the same method we do here. In order to solve for X, we're going to take 2, multiply it by 16. So we have 2 times 16 equals 8 times X. Two times 16 is 32. Since 8 is multiplied by X, we're going to divide both sides by 8. Which gives me, and I'm going to draw it up here so it's not so low on the board, which gives me 4 equals X. So as many of you predicted, there will be 4 male students. All right, so let's look at example 6 here. I still have some people writing, so I'm going to pause for one more second. All right. So example 6 says, Amy always uses 3 of the 4 pencils she brings to class. If she was to bring 8 pencils to class, how many would she use? All right. So example 6 says that Amy always uses 3 of her 4 pencils. So we could write this as 3 used pencils to 4 total pencils. No, sorry. Hold on, better way to write this. 3 pencils are used to the 4 pencils brought. It's not the nicest sounding sentence, but it kind of gets the point across. So 3 pencils are used to the 4 pencils brought with her. So that means the ratio in general is 3 to 4. So then the question is, how many pencils are used if Amy brings 8 pencils? assuming the ratio stays the same. And you might think to yourself, how does someone use 3 out of 4 pencils? But I actually do that. When I sit and take notes, I take like 4 pencils and then I just like switch them out randomly for no reason whatsoever. Like they don't get dull. I think I just get bored with them. And so I'm like, I don't like this color pencil anymore. And I change. That's why I became a math major, because then I should use pencils all the time. All right, so here we're gonna set up our ratio. So we have X, because we don't know how many she uses, but we know that there are 8 total. All right, so now I'm going to convert each of these to fractions and set them equal to each other. So we're going to have 3 over 4 equals X over 8. The important thing to remember is just like when we did the proportional equations the other day, whenever you have things like this, we want to keep the same unit in the numerator and the same unit in the denominator. So here, the top represents used pencils. So 3 used pencils and an unknown number of used pencils. The bottom represents the total number of pencils that Amy brought with her. All right, so now we cross multiply. 3 times 8 equals 4 times X. All right, 3 times 8 is 24. We have 24 equals 4X. We're going to divide both sides by 4 in order to get the X by itself. So that means that 6 equals X. So if Amy uses the same ratio of pencils as she did before, but this time she brought 8, that means she's going to use 6 of them. And for those of you who do like fractions, you'll notice that 6/8 is the same thing, can be reduced to 3/4. All right, okay, so now we're going to look at, so your homework, it's gonna feel like we're doing the same thing over and over again, and it's because we are, but I wanna make sure you see the different ways your homework writes it. So your homework asks you to do the exact same thing, but in like 6 different formats, it feels like. So I'm gonna show you another format they ask you. They give you the word problems like we've done, and then they also give you this. They say, this is actually example 6. Fill in the missing blank for this equivalent equation. And I think on y'all, this might be example 7. Is it example 7? Okay. Yeah. Thank you. Because I remembered I put 2 6s on mine and then I caught it when I was making y'all's handout. I was like, oh wait, that should be 7. All right. And then the ratios it gives you is 10, 15 equals X to 45. Let's see. I think we're back to you, Tanya. Okay, all right, so if I was to write 10 to 15 as a fraction, how would I do it? It's not working for me anymore. Let's see if this works better. All right, and how would I write X to 45 as a fraction?
X and then 1.
Perfect. All right, Jayton, what would I do next now that I've converted them to fractions? Cross multiply. All right, so what's 10 times 45? Just add a 0 at the end. 450. And then what's 15 times X? 15X. You're like, are these trick questions or? Well, they're not. He's got them all right. All right. Taylor, can you see well enough to answer? Should I go on to Rebecca? Rebecca's like, if you throw me under the bus, this friendship's over. What would be our next step? I have 450 equals 15x.
Bottom,
We're going to divide. What are we going to divide by?
15.
Yes, yes, perfect. Divide by 15. All right, and I will tell you guys, that comes out to be 3. So x equals 3.
Bless you.
Thank you.
Is it 30? Okay, it's 30. Okay, we're fixing my notes here. Okay. All right, okay, so now let's look at what is your example 8. And why don't I just let you guys do example 8 and then your turn on your own. So you guys give those a shot and then we'll work through it. So do example 8 and the your turn on your own. You guys seem to be getting it, so I'm confident that you can figure it out. Make sure I give you enough details. All right, about 1 more minute and then we'll talk from as a class. All right. Okay, so let's look through example 8 first. And Rebecca, we are to you. So can you tell me what ratio did you write for example 8?
I wrote the 1 to 2 and then the 3 to 8.
Okay. Okay, so we'll start with 1 to 2. But yes, okay, so we'll start with 1 to 2. So she wrote 1 to 2, or if you wanted to write out the words, you could say 1 cup flour to 2 eggs. All right, so this is the ratio because it says the recipe calls for 1 cup of flour for every 2 eggs. Okay. All right, and so then the second question says, if you add 3 cups of flour, how many eggs will you need to add? So this is the part where Rebecca said that she got the ratio 3 to X, and that's because we have 3 cups of flour to X eggs, because we don't know how many eggs. All right, okay, so Rachel, how would you convert this ratio to a fraction?
2 over 3.
So we want to, so this number goes in your numerator. And this number goes in your denominator.
I'm sorry, I was looking at the wrong thing.
Oh, okay.
2 over 1.
Okay, so 1 over 2, so flip it.
1
Uh-huh,
over 2.
yep, okay. And then what about 3 to X?
X over 3.
3 over X. So the first number goes on top, and the second number always goes on bottom. All right, so here we have our equation. So we are to Mariah. Mariah, what should I do now? Cross multiply. Okay, so I'm going to get X equals 6. Didn't even have to do any dividing on that one. All right, so that means if you have 3 cups of flour, you should have 6 eggs. And I could stick it in here. There we go, 6 eggs. Any questions about how I got this answer? Or I didn't get it, y'all got it, I just wrote it on the board. All right, okay, so you guys seem to have this pretty good, so I'm gonna skip the your turn. If you have any questions on it, the answer should have been 4. So if you didn't get 4 and you have any questions, you can ask me after class. But right now, we're going to play the trash get ball, okay? All right, so if you turn to the very last page of your handout, you'll see an activity sheet that gives you directions. So all I need to do is put you guys in pairs and then let you start. Okay, so this is going to be your goal, all right? So how I want it to work, or we can at least try, it's the first time I've ever done it, we can always change it, being partway through it doesn't work. All right, so I'm not sure how far you guys want to test your skills, all right? So what I can say is let's put the basket at this end of the table and someone stand here and shoot. If you feel like your sports prowess is not being challenged adequately by this distance, you are feel free to step back, okay? It's up to you. But you must, but what you cannot do is you cannot stand here and drop 10 paper balls into the basket. Yes.
I feel like it's cheap. I have to probably want to walk as hard.
Okay, you must toss it appropriately, okay?
I shouldn't have said it.
But you have to be at least a table length away. So I'm gonna leave this here, and then I'll give you guys the rest of the basket. So I'm just gonna number you off 1 through 4. The sheet only has space for 2 people per group, but we have an odd number, so one group's gonna have 3, so just fill in a spot for you underneath. All right, so I'm gonna start with you, and we're numbering to 4. Lisa's 3.
4. Of 1.
2. 3. And Tanya, you're 1. All right, okay, so there's only 4 groups, so, okay, 1, you can be back there where I already put the green basket.
Because you should make 3 groups. 3 each.
Well, yeah, but the thing only has space for 2, so, okay, so then here's for group 2, and we'll put group 3 here, and group 4 can be here. And I will give you your 1 piece of paper. All right, so 1, 2, 3, 4. I'm gonna go ahead and put them in the basket so they don't roll away. And you guys are lucky there's no wind in here. All right, okay, so you guys go ahead. 1, 2, 3, 4. If you have any questions about the directions, let me know. And if you lose one of your paper balls and you can't find it, then I have an extra.
Yeah, everybody, and yeah, when I was in high school, I started a lot because somebody was taking it
Oh, when you finish yours, if you could hand it in, just so I can check them and make sure we understand.
I just.
Oh, yeah, just go ahead. You guys can start, yeah. Somebody makes 1 and forgets 0 over 10. Oh, Rachel got 1, good, okay. Oh, Jaden got 1, there you go.
That's why I played right after going. I understand.
No. Good thing they're paper and not like metal, right, Lisa?
Three out of 8.
Oh, wait, we're starting off on a road. Yeah, we're all sorry.
It's getting three.
How was
I
it
know, right?
great? It's
I know, right?
I
Bouncing right back.
bought the magic basket for $3.
Lime green.
Okay, so not to tell Mariah on my
This
team,
is
but I
four
play
tracks.
basketball.
5 and 8.
I did not play anything.
6 and 9. 7 and 10. This is four tracks.
How's Taylor doing?
Straight up beat.
Oh.
It was bad. I knew this was one-sided.
Well, I did.
Missed as many as I was making. Like I said, it's because I'm very fun. I'm not.
All right, so once you guys have both gone, you'll fill up your,
Look at one side.
okay, so for your ratio representation, what you want to do is do this for six.
Yeah.
3 made out of 10. No, it's not.
5, 800, 5.
And then you'll use here, so now you're gonna do the math. If there were 20 attempts allowed, how many would you make? And then that's how it works.
I would've
How many
made
would you
6.
make? And then write your ratio.
I would've made 6.
Yes, you would make 6. So you put 6 over here, and then, 6 out of 20, yeah.
I would've put-
Yeah, so you're putting, yeah, I don't know, yours would be different, right? You would be whatever,
Oh,
for yours, yeah,
okay.
yeah. If you work on them together, so you help each other and all
Oh, this is for.
that. Yeah, or do your own.
Oh, boy.
Yeah, I am.
That's
Yeah, okay, so you want to set.
I was just, okay, how many shots?
You
You
have
you actually need.
equal X over. And let me, if you want, you can just use the board and write on the board if you need. I'm gonna write an example equation up here for if you guys need it. When you get to the bottom part and it says, how many would you have made if there were this many shots? You set it up by number of shots made out of 10 equals X over the number of shots they are asking about. So for the one that says, if you would have had 50 shots, say that you were like Rebecca and you got 7, then you would have 7 out of 10 equals X over 50, and you would solve for X.
Does it go out?